What's up, everybody, and welcome back to OpenStax Algebra and Trigonometry, Chapter 9, Section 4, Sum to Product and Product to Sum formulas. Let's do it. So this says, starting with this formula, explain how to determine formula for cosine A sine of B. So all we're doing is wherever there's a beta, now we're replacing it with an alpha. Wherever there's an alpha, we're now replacing it with a beta. So let's do that now. So now we got 1/2, and we've got sine of beta plus alpha plus sine of beta minus alpha. Now, once we are in this position, we can do something interesting, right? B minus A, because I want us to still, we're trying to get back to that A plus B, A minus B situation. So this I can just reformat as sine of A plus B. And then over here, what I can do is I can actually factor out a -1, okay? Because that's the exact same thing as B minus A. It's -1 times A minus B. And then if you remember, it's the same as this, but with a -1. So it's that argument negated. And since sine is an odd function, I can pull that negative out and bring it in front of the sine like this. And then now we have sine of A minus B like so. And this is the formula, right? This is how we get cosine of A sine of B. It equals this exactly. So that's how you do it. Boom, done. So for this question, I'm going to use the example from the back of the book to show how we can turn sum to product into a benefit. So here we've got this, and we're gonna use this formula, right? Sine of something plus sine of something. All right. So how can I convert this? Well, this is the same as saying 2 sine, okay, for the numerator of A plus B, which is 3x plus x, which is 4x. And then this is all divided by 2 times cosine of A minus B. That's 3x minus x, which is 2x over 2. And again, remember, this is all over cosine of x. Okay, now 2x over 2 reduces to just x. So cosine of x over cosine of x, these cancel out. Now we have 2 sine of 4x divided by 2 is 2x. Now we can set this equal to 1 and then solve from here. It becomes much easier, right? You divide by 2, we got sine of 2x equals 1/2, and so on and so forth. And now we can see, like, all right, what are the values of x that are going to give me a value of 1/2? Let's just say, for example, in the first quadrant. Well, I know that sine of pi over 6 is going to give me 1/2. I'm just giving one example. So 2 times what is going to give me pi 6? That's pi 12. So just as an example, in radians, this would yield an answer of pi 12, and we'd use this to get there. So that's a great example. Boom, done. For the following exercise, rewrite the product as a sum. So we're going product to sum, which is down here. And we got sine. So that is this identity down here. So I'm going to call A the first argument, which is 16x. And I'm going to call B the second argument, which is 11x. All right. So, and we'll leave the 16 out for now. We got sine of something, sine of something. So let's convert it. So that becomes 1/2 cosine of A minus B, 16x minus 11x is 5x, and then minus cosine of A plus B. So A plus B would be 27x, okay? And then we still got the 16 that we can't forget about in the front. So that's going to multiply this 1/2. So now we're left with a final answer of 8 cosine of 5x minus cosine of 27x, like this. And we'll leave it as such. Boom, done. So for this one, we got a sine cosine situation, and that is going to be this one right here, sine cosine. All right, so let's apply that. And let's set A as the argument for sine up here, which is 5x. We'll set B equal to 3x. All right, and again, we have a 2 out front. So let's actually include the 2 for now. And then we've got 1/2 sine of A plus B, which is 8x, plus sine of A minus B, which is 2x, so that's sine of 2x. And then if we distribute the 2 in, times 1/2 is just 1. So our final answer is sine of 8x plus sine of 2x. That's how you do it. Done. For this one, we have sine, which is down here, so we're going to apply that. I'm going to set A equal to that -x. I'm going to set B equal to 5x. All right, now let's write it out. We got 1/2 cosine, and this is in parentheses, of A minus B, -x minus 5x is -6x. And then it's minus cosine of a plus b, negative x plus 5x is 4x, so cosine of 4x. And at this point, this is pretty much good to go. One thing we can do is we can utilize the even property of cosine, which is that cosine of negative x is the same as cosine of positive x. So I can just rewrite that negative 6x as cosine of 6x minus cosine of 4x. It's the same thing. Now again, it might be up to your teacher which one they prefer, but this is what they have in the back of the book. So that's what we'll roll with. Boom, done. For this one, we're going sum to product. So I see cosine plus cosine, that's right here. So I'm going to set a equal to 6t and b equal to 4t. And now let's write it out. So we start out with 2 cosine of a plus b over 2, so that would be 10t divided by 2 is 5t. And then we have cosine of a minus b divided by 2, that's 6t minus 4t, which is 2t divided by 2 is just t. That's how you do it. Done. So for this one, we got cosine plus cosine, and I see that right here, so that's what we're going to use. By the way, I'm going to use the property of cosine such that it's an even function, that cosine of negative x is cosine of x. So this is the same as just cosine of 7x plus cosine of 7x. Now what's interesting with this is this literally becomes, you don't even need the sum to product rule, it just becomes 2 cosine 7x, right? That's logical. But let's go through the process and I'll show you how that works as well using these formulas. So a would be 7x, b would be 7x, and then we get 2 cosine a plus b divided by 2, which is 14x divided by 2, which is 7x, so it's 7x, and then times cosine of a minus b, 7x minus 7x is 0 divided by 2 is 0, cosine of 0 is 1. So you see you get the same thing. So there's your answer, done. For this one, we got the cosine plus cosine right here. So I'll make a equal to 3x, b equal to 9x. All right, let's do it. So we got 2 cosine of a plus b divided by 2. 3 plus 9 is 12 divided by 2 is 6x. And then times cosine of a minus b, 3x minus 9x is negative 6x, divided by 2 is negative 3x. And again, because cosine is an even function, that negative can be just negated to a positive, because cosine of negative 3x is the same as cosine of 3x. So that's how you do it. Boom, done. So for this one, we got product. We're going to turn it back into a sum. So I see cosine, cosine right here. So I'm going to set a equal to 45 and b equal to 15. So then what we have is 1/2 cosine of a minus b, which is 30, plus cosine of a plus b, which is 60. Now, the good news about both of these, let me make that nice square bracket. The good news about both of these is we know what they are, right? We can look at the unit circle, but if you recall, cosine of 30 is rad 3 over 2. Cosine of 60 is 1/2. So then we have this, and then we have a 1/2 times it, so let's distribute. So then we have rad 3 over 4 plus 1 over 4. And now I could consolidate it to have a single denominator, but the way that they wrote it in the answer key is they factored out 1/4 from this, and then they have rad 3 plus 1 like this. So there you go, all equivalent, done. So for this one, we have sine times sine, so we're going product to sum, and I see sine times sine right here. So I'm going to set a equal to negative 345. That first argument, b will be negative 15. So then we're going to get 1/2, and then we got cosine of a minus b, which would be negative 345 plus 15, right? Minus a negative is a positive. So that's negative 330. And then that is minus the sum of these two. That would be negative 360, right? Cosine of negative 360. Just so you can see, I put the unit circle back up here so you know where I'm getting this stuff from. By the way, negative 330 is coterminal with, if I add 360 to that, it's coterminal with 30. So I can just take cosine of 30. Cosine of negative 360, that's coterminal with 0. So I can just take cosine of 0. So cosine of 30, here's 30 degrees. Cosine is that x value, which is rad 3 over 2. And then minus cosine of 0. Cosine of 0 is positive 1, so minus 1, like so. And then if we factor out a 1/4 from here and here, or sorry, 1/2 from here and here and bring it outside, 1/2 times 1/2 is 1/4, okay, times radical 3 minus 2. Now, this is how they have it in the back of the book. This, by the way, is the same thing. It's also equivalent, but we can say this will be our final answer. Boom, done. For this one, we're turning sine product into sum, so that's right here. So I'm going to set a equal to negative 45 and b equal to negative 15. So first of all, we have 1/2 times cosine of a minus b, that's negative 45 minus negative 15, which is actually negative 30. And then that's minus cosine of the sum of these two, negative 45 plus negative 15 is negative 60. All right, so a couple ways we can approach this. Number one, we can find coterminal angles, but the second way is recognize that cosine of negative 30 is the same as cosine of positive 30 because it's even. It's an even function. Same with this. So I can just take cosine of 30, here's 30, here's cosine of 30, rad 3 over 2, minus cosine of 60, here's 60, and it's 1/2. So these two are going to be subtracting and then times 1/2. Now again, this is fine as is, but if we want to factor out a 1/2, which is how they have it in the back of the book, I pull out a 1/2. 1/2 times 1/2 is 1/4, and then we've got rad 3 minus 1 on the inside. So that's how you do it. Boom, done. So we got sine here, so that looks like this. So I'm going to use this formula. And by the way, if I multiply both sides by 2, right, I'm actually going to get 2 sine A sine B, which means it's the same thing as this. I just don't need that 1/2. So it's going to be cosine of A minus B minus cosine of A plus B. So let's write that out. So first, A is that first thing, which is 100. B is the second one, which is 20. So then it's cosine of A minus B, which is 80, minus cosine of the sum of these two, which is 120. And that's it. That's how you do it. Done. For this one, we have a sine times that's sine. We got a sine times cosine situation, excuse me. And that's equal to, and let's set A and B. A is the first angle, 213. B is the second angle, 8. So we got 1/2 times sine of the sum of these two, which is 221. All right, plus sine of the difference of these two. Oh, this whole thing is in parentheses, by the way. Sine of the difference, which is 205, all right? And in the answers, they didn't distribute the 1/2. They left it like this. So let's leave it like that. There you go. Done. So for this one, we got a sum of sine plus sine, which is right here. So to turn into a product, it's set A as 76 and B as 14, okay? So then we have 2 sine of the average of these two added together, which is 90 divided by 2 is 45, okay? And then times cosine of A minus B, so 76 minus 14, what is that, 66, 62, divided by 2 is 31. And it said to leave it like this, except for the fact that sine of 45 from the unit circle can be determined. That's rad 2 over 2. So I may as well put that in. This is going to be, something that's not from the unit circle, so it's going to be an approximation. So we'll just leave that as cosine of 31. And then the 2 and the 2 cancel out, so we're left with the most simplified version, rad 2 cosine of 31, boom, done. So for this one, we got sine minus sine, which is right here. Now I'm going to set A to 101 and B to 32. All right, let's apply it. So then I got 2 sine 101 minus 32, which is 69 divided by 2. And then I've got times cosine of 101 plus 32, which is 133 divided by 2. And then I'll just do that in decimal format. So 69 divided by 2 is 34.5. 133 divided by 2 is 66.5. So that's how you do it. Boom, done. So for this one, we have sine plus sine, and that is this top one. So let's set A equal to -1, B equal to -2, and then let's plug it in. So we got 2 times sine of the sum of these, that's -3 divided by 2. And then we've got times cosine of A minus B, -1 minus -2, it just becomes 1 divided by 2 is positive 1/2. And then we know that sine is an odd function. That means sine of a negative is the same as negative sine of that positive, which means I can basically pull this minus sign out and put it in front. So my final version would be -2 sine of, let's put that in decimal format, 1.5 times cosine of 0.5, or leaving it in, which is equivalent, but this is how they have it in the back of the book. Either way, -1.5 inside cosine of 0.5 like this. So either of these are legit. Boom, done. So for this one, we're meant to prove this identity. So we're going to take this, and I see this as a product of sine times cosine, right? So that is right here. And in that case, A would be 3x and B would be 4x. So what I'm going to do is I'm going to expand this out using the product to sum, and let's see what we get. So first of all, and we have that 4, and then we have the 1/2, and then we've got sine of a plus b, so that's sine of 7x, okay? And then it's plus sine of the difference of these two, which is sine 3x minus 4x is negative x, so then it'd be plus sine of negative x. Now, by the way, because sine is an odd function, sine of negative x is the same as negative sine of x. So I can go ahead and make that change. Last but not least, let's distribute in the 4. That's going to be 2. And then I'm going to distribute the 2, right? These are still parentheses around both the signs. The 2 is going to distribute to that and that. So my final answer will be 2 sine of 7x minus 2 sine of x. That's how you do it. Done. For this one here, we got sine plus sine. So I'm going to use this formula and see if we can get this to verify the identity. So I'm going to set a equal to x and b equal to 3x. All right. Here we go. So it becomes 2 sine of a plus b divided by 2. That'd be 4x divided by 2 is 2x. And then we have cosine of a minus b, x divided by 2. X minus 3x is negative 2x divided by 2 is negative x. So we have cosine of negative x. Now again, cosine is an even function, which means cosine of negative x is the same as cosine of x. So we can just get rid of the negative. And then we got this 2 sine of 2x, all right? So it doesn't look exactly the same, but if you remember, sine of 2x in our double angle identity is the same as 2 sine x cosine x, right? So then I've replaced that with that. We still have the 2 in front, and then we still have the cosine of x in the back. And then when these guys multiply, we end up with, and these multiply, we end up with 4. That sine of x stays as is, and then we have cosine x times cosine x, which is cosine squared x. And guess what? That's what we had on the right side. Identity verified, boom, done. So for this one, what I'm going to do is I'm going to start with this tangent, and I'm going to turn it into sine of x over cosine of x, okay? And then cosine of 3x stays as is. Now, the reason why I'm doing this is because now I'm going to pull the cosine x out in front, and that's 1 over cosine of x. What is 1 over cosine of x? It's secant of x. So this is already looking pretty good. So I'm going to pull that out as a secant of x. And then I don't really need these parentheses, but let's include them anyways. And then I've got 2 sine, oh, I'm missing a parentheses there, 2 sine of x cosine of 3x, okay? Now I can use my nice sine x cosine x product to sum right here, sine x, sine of a cosine of b. So I'm going to set a equal to x, b equal to 3x, all right? Now we're going to apply it. And we're going to write this in. By the way, the 2 and the 1/2 are going to cancel out, so I don't even need to write that 1/2, okay? So now we're left with secant of x times. So again, the 1/2 doesn't need to be written. Then I got sine of a plus b, that's 4x, so that's sine of 4x, and then plus a minus b, that's x minus 3x, which is negative 2x, okay? Now, because sine is an odd function, that negative can kind of come out, which means sine of negative x is negative sine of x. So I can just rewrite it as secant of x times sine of 4x minus sine of 2x like this. And guess what? It's exactly what we have here. Identity has been verified, done. So for this one, we're going to rewrite it from sum to product. So we got cosine plus cosine, which is right here. So I'm going to set a equal to 58 and b equal to that second angle of 12. So this is the same as 2 times cosine of a plus b, which is 60, 70 divided by 2 is 35. And then times cosine of a minus b divided by 2. 58 minus 12 is 46 divided by 2 is 23, okay? And now let's evaluate this in Desmos. So again, make sure you're in degrees mode, not radians, because this was in degrees. So it's 1.5081. So 1.5081, boom, done. So for this one, we got cosine minus cosine, which is right here. So I'm going to set a equal to 44 and b equal to 22. And then I got negative 2 sine of a plus b, which is 66 divided by 2 is 33. And then sine of a minus b, which is 22 divided by 2 is 11, okay? So we got sine 33, sine 11. Let's plug it into Desmos. And we get negative 0.2078. So that's how you do it. Boom, done. For this one, we got sine times sine, and we're converting it to the sum. So let's do that here. So we got A equal to the first angle, negative 14, B equal to the second angle, which is 85. So then we got 1/2, and then we got cosine of A minus B, that's negative 99, excuse me, and then minus cosine of A plus B. So negative 14 plus 85 is 71. So we got minus cosine of 71. Now, not that this really matters, but again, cosine is an even function. So cosine of negative 99 is the same as cosine of 99. So we can just simplify like that. Now let's plug it into Desmos. And here we get negative 0.24410. So there's the final answer. Done. So for this one, we need to determine whether or not it's an identity. So what I'm going to do is I'm going to use my sum to product. I got cosine plus cosine and cosine minus cosine. So that's these two down here. So for the top one, I'm going to set A equal to 10 theta and B equal to 6 theta. And then for the bottom one, I've got to kind of flip-flop, right? The first value is 6 theta, and then the second value is 10 theta. So first starting with the numerator using the bottom, right? That's 2 cosine of A plus B divided by 2. That's 10 plus 6 is 16 divided by 2 is 8 theta, all right, times cosine of A minus B divided by 2. 10 minus 6 is 4 divided by 2 is 2. So that's 2 theta, like so, over, and then down here we have the difference. So then it's negative 2 sine of A plus B divided by 2. That's again 16 divided by 2 is 8 theta. And then it's sine of A minus B divided by 2. 6 minus 10 is negative 4 divided by 2 is negative 2. All right, now because of the odd function of sine, sine of a negative argument is the same as negative sine of that argument. So I can basically take this minus and bring it outside, but that makes a double negative, which just cancels that out. Now we got something really cool, right? 2 over 2 is 1. Cosine of an argument over sine of an argument is the same as cotangent of that same argument. So in this case, it'd be 8 theta. And then cosine over sine of the same argument again is cotangent, and this time of 2 theta. And guess what? That's what we had on this side. Just the order's different, but it's the same thing. And just so you can see in Desmos, this is the side on the left, the expression on the left. This is the one on the right. And look at this. They're right on top of each other. So again, that verifies that this is indeed an identity. So for this one, I'm going to turn product into sum and product into sum. We're going to see if we somehow end up with this. So first of all, for this piece, it's cosine cosine, right? So that is right here. So then I'm going to say A is 2x. B is x. Okay, let's see what we get. So we get 2 times 1/2. So those are going to cancel out. I'm not even going to write it, right? 2 times 1/2 is 1. And then I got cosine of A minus B, which is just x, plus cosine of A plus B, which is 3x. Then for the second part, I got sine of 2x, sine of x. That is sine times sine, which is right here. So for this one, I got A equal to 2x and B equal to x. And this one I can rewrite as plus 1/2 cosine of A minus B, which is cosine of 2x minus x, which is just cosine of x, minus cosine of A plus B, so that is 2x plus x, which is 3x. So now as I kind of distribute everything and then combine like terms, half of cosine x plus cosine x is 3/2 cosine x, and then cosine 3x minus 1/2 cosine 3x is just regular 1/2 cosine 3x. So we're going down this path and we get here and we're like, all right, this is clearly not 2 sine of x. So I would say, no, this is not an identity. But there is a way to get something a little bit nicer, similar to sine of x. And what I'm going to use here to get what they've said is equivalent to it in the back of the book is I'm going to use my double angle identities, all right? So I got cosine of 2x and I got sine of 2x. So I'm going to use my double angle identities. So cosine of 2x, I'm going to plug in cosine squared minus sine squared. So I'm replacing cosine of 2x with cosine squared x minus sine squared x. And then over here, I'm replacing sine of 2x with 2 sine x cosine x. And then we have that other remaining sine of x here. Okay, so this is pretty interesting because when I distribute like this, I first get 2 cosine cubed x, then I get minus 2 cosine x sine squared x. And then here, when I multiply these two signs together, I kind of get something similar to this. I get plus 2 cosine x sine squared x. Well, guess what? That's negative, that's positive, and they're the same, so they cancel out. So we're left with 2 cosine cubed x. And 2 cosine cubed x is equivalent to this entire left side, not 2 sine of x. That's how you do it. Done. So for this one, I'm going to use the sum to product rules. Here I got sine minus sine, which is right here. So we're going to start with the numerator first. I'm going to set a equal to 9t and b equal to 3t. So that's going to be the same as 2 times sine of a minus b divided by 2, that's 6t divided by 2 is 3t, times cosine of a plus b divided by 2, that's 12t divided by 2 is 6t. All right, so that's my numerator. Now let's look at the denominator. It's cosine plus cosine, which is right here. So that's 2 times cosine. Oh, and by the way, the a for this is the same. It's 9t, and the b for this is also 3t, right? A and b. So it's cosine of a plus b divided by 2. 9 plus 3 is 12, divided by 2 is 6t. And then we have a minus b divided by 2, which is 6t divided by 2 is 3t. And then these guys cancel out. Sine of an argument over cosine of the same argument is equal to tangent. 2's cancel out, so we're left with tangent of 3t. Now we're going to graph the original and this one in Desmos to confirm that they are indeed equivalent. So here's the original function on the top in red, and then when I show this one in green, check it out, it's right on top. So that verifies it. They are equivalent. Done. So for this one, I got sine minus sine on top. We can use this one, sum to product, where a is equal to 3x, and then b is just that lonely x there. And then it's equivalent to 2 sine of a minus b, which is 2x divided by 2 is just x, times cosine of a plus b divided by 2. 3x plus x is 4x divided by 2 is 2x over sine of x. Guess what? Cancel, cancel. And we're left with 2 cosine of 2x. All right, let's plug this into Desmos and make sure it's the same as this. So here we can see the first original equation, and here is the new equation, which is just one trigonometric function. You can see they're equivalent, they're identical. That's how you do it. Done. So for this one, we got sine times cosine, and then we got minus cosine times sine. But I'm going to use the product to sum to simplify this. So first of all, sine times cosine is here. So I'm going to set a equal to x and b equal to 15x. So here we've got 1/2, and then we've got sine of a plus b, which is 16x. And then we've got plus a minus b, which is negative 14x, right? X minus 15x is negative 14x. And then minus, and then we got cosine times sine, which is occurring here. And here I'm going to set a equal to x and b equal to 15x, okay? So then we have, for the second one, 1/2, and in brackets, sine of a plus b, so same thing, sine of 16x. And then it's minus sine of a minus b, that's negative 14x. Now, because sine is an odd function, sine of a negative value is the same as negative sine of that positive value, which means I can basically remove this negative here as long as I bring it out here. So that would make this negative. I can do the same thing, remove this negative out here, but that's going to flip that to be a plus. Okay, cool. Now let's distribute the halves like here, and that's going to be distributing a negative 1/2. So now we got positive 1/2 sine 16x, negative 1/2 sine 16x, cancel, and those cancel out, right? And then I've got negative 1/2 and negative 1/2. Those are going to add together to be just negative sine of 14x. Now let's graph both of these in Desmos and make sure they're equivalent. So here we have the original function graphed in red, and then the new function in green. Check it out. It's the same. It overlaps. They're identical. Done. So for this one, we're going to start by setting x equal to a plus b and y equal to a minus b. Then I'm going to substitute this in here, and I'm going to substitute this in here for y. Now I'm going to use the sum and difference formulas to simplify. So cosine of a plus b is going to be cosine A cosine B, right? Minus sine A sine B. And then it's going to be plus, and then for the minus one, right, it's going to be cosine A cosine B. And then when it's minus, it's actually plus for cosine. And then it's going to be plus sine A sine B, just enough room. Now this is negative sine AB, this is positive sine AB. Cancel, cancel. And then we add these together and we get 2 cosine A cosine B. Now all we have to do is plug back in for x and y. So right now, how do we get that? How do we get A and B in terms of just x and y? Well, look at this up here. I got a beautiful system of equations that we had created. So if I add these two equations together, I get something really cool. I get x plus y on the left-hand side equals a plus a is 2a, b plus negative b just cancels out. So if we divide by 2, check it out. a equals x plus y over 2. So I can substitute x plus y over 2 in for a. Now, what about b? So if I know that a equals x plus y over 2, I can kind of plug it in here for a. And now if I want to know what b is, I just got to isolate it. So I can first multiply everything by 2 just to make it easier. Then it's 2x equals x plus y plus 2b, right? Because the 2 just cancels out. We got x plus y, and then we have 2 times b. Then I'm going to subtract x from both sides, and then I get x. I'm also going to subtract y from both sides, and I get minus y equals 2b. Last but not least, we're going to divide by 2. And guess what? b equals x minus y over 2. So subbing in for that, I got x minus y over 2. And guess what? We've just proven this formula. That's how you do it. Done. So for this one, we're going to prove this identity by using our sum to product. And here I got cosine plus cosine and cosine minus cosine. So let's do the top first. A would be 3x, right? B would be just regular x. And then it's going to be 2 cosine a plus b divided by 2. That's 4x divided by 2 is 2x times cosine of a minus b, that's 3x minus x is 2x divided by 2 is just x. Now for the second part, we've got cosine minus cosine, so we're going to be using this one. And a and b are still the same, 3x and x. So now we have negative 2 sine of a plus b divided by 2, that's 4x divided by 2 is 2x. And then we've got, that should be sine again of a minus b divided by 2. Again, that's just x, just like we have up top. Now this is pretty cool because negative 2 divided by 2 is negative 1. And then cosine over sine is cotangent of that same argument of 2x. And then cosine over sine again is cotangent of that same argument, which is x. And guess what? We just verified the identity. Done. For this one, I got cosine minus cosine, so we're going sum to product. So we're going to start here. And a is going to be 2y, b is going to be 4y. So let's apply that. So that's going to be negative 2 sine of a plus b divided by 2. That's 6y divided by 2 is 3y. And then times sine again of a minus b. 2y minus 4y is negative 2y divided by 2 is negative y. And that's all going to be over. And then now on the bottom, we got sine plus sine. That's right here. So a and b are the same, so I'm going to leave that. So then we have 2 sine of a plus b divided by 2, which is again 3y. And then cosine of a minus b divided by 2. Again, that's negative 2y divided by 2 is negative y. So now sine of 3y over sine of 3y cancels out to 1. Negative 2 over 2 cancels out to negative 1. And sine of negative y over cosine of negative y is tangent of negative y. And again, there's a negative in front here. Now, the cool thing about tangent is it's an odd function, which means that tangent of negative y is the same as negative tangent of y, which means it would be negative tangent of y. Those negatives would cancel out, and we're left with just tangent of y. That's what we have here. Identity is verified. Done. For this one, I'm going to choose sum to product. It's cosine minus cosine right here. So I'm going to set a equal to x. That first one, b is equal to 3x. So this will become negative 2 sine of a plus b divided by 2. X plus 3x is 4x divided by 2 is 2x. And then again times sine of a minus b. X minus 3x is negative 2x. Divided by 2 is negative x. Okay, using the odd property of sine, I can take that negative out essentially and put it to the front, which is going to cancel that out. So this becomes just 2 sine 2x sine of x. All right, now using my double angle identity, sine of 2x is the same as 2 sine x cosine x. All right, and then we got the sine x out here. Now I can multiply these two together, multiply the 2 times 2 together, and I get 4 sine squared x cosine x. That cosine just stays as is. That's how you do it. Identity verified. Done. So for this one, I'm going to use the sum difference identities. I'm going to use tangent of x minus y. And we're going to rewrite it as tangent of pi fourths. That's the first value, right? That's our x. Minus tangent of t. And then that's over 1 plus tangent of, again, that first argument, pi fourths, times tangent of the second argument, which is t. All right, what is tangent of pi fourths? So if we look at the unit circle, pi fourths is coming out right here. And if you look at the unit circle, the coordinates of this are rad 2 over 2 rad 2 over 2. They're the same, right? And tangent is always y over x. So y over x in this case, since they're the same, is just 1. So guess what? That becomes 1 minus tangent of t. And then on the bottom, we have 1 plus, again, that's 1. So it's 1 plus tangent of t. And guess what? It's exactly what we have here. So there you go, identity verified, done. I hope you guys enjoyed this video, and if you did, please click that like button. If you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.